Alright, here's our logarithmic functions worksheet 2.3. So these first, we're just going to rewrite some fractional exponents. Okay, so remember, whenever we have a radical, we can turn it into an exponent in the fraction form. Whatever type of root it is, that becomes the fraction. So this would be x to the 1/5. Here we have squared, so anytime there's a number in here that's being squared, that number goes up to the top, so that would be like s to the 2/7, w to the 8/3. Okay. Now number 4, we'd have 8 to the 1/3 and r to the 6/3. Well, 8, or cube root of 8, or 8 to the 1/3 is 2, because 2 times 2 times 2 gives us 8. So that can reduce to 2. And 6/3 would also be 2, so that would reduce to 2r squared. Okay, then we've got 125 to the 1/5, m to the 5/5, which that would just become 1, so we have m. Now 125, okay, can we take the 5th root of 125? 5 times 5 times 5 is 125, so we can't. So we just leave it like that. Okay, now this whole 8 is squared, so you could think of it as 8x to the 2/3, but that won't help you as much. Okay, it's better to kind of think through it and say 8 is 64. What times what times what? Could be 64 to the 1/3. Okay, and we get 4. 4 times 4 times 4. So 64 to the 1/3 would reduce to 4. X squared would just be x to the 2/3. Okay, then we'd have 9 to the 1/3, b to the 8/3, can't reduce either of those, and then 75 to the 1/2, x to the 6/2, which we can reduce that to 3. Okay, and that's what we do for the first part. Okay, then we do it with logs, so same idea. So I'm just going to reduce that, so I'd get log base 3 of 3 to the 1/5. Well, if you recall, what would that equal? Well, we take turn it into an exponent, it'd be 3 to what power is going to equal 3 to the 1/5. Right? So anytime we have those two matching up, your answer is just going to be right there. So it'd be 1/5. Okay, for 10, we would have log base 2 of 3 to the 4. Well, 4 is really like 2 squared, right? Because I could rewrite this log base 2 of 4 to the 1/3, and we don't have that connection. But if we realize that 4 is really this to the 1/3, it's really like 2 to the 2/3, so our answer would be equal to 2/3, because those would essentially cancel out when we think about it. Okay. 343, because we have a base of 7, we want to see if it's 7 to the something. Well, 7 times 7 is 21. Times that by 7, and we get 147. Okay. Wait, whoa. 21. Oh my goodness. I was thinking 3 times 7. Because I believe 7 times 7 times 7 is equal to that. It's 49 times 7. That looks better. 3, 6, 28, yeah, 34. So that's really like log base 7 of 7 cubed to the 1/5, which would be 3/5. And then, we'd go 7 to what power equals 7 to the 3/5, so we know our answer is 3/5. Okay? Then number 12, 3,125. We have a base of 5, so it's 5 to what power? Okay, would equal 5 to the, we'd have 1/5, 5 to the something to the 1/5, right? So 5 times 5 is 25, times by 5 again, that's 125, times by 5 again, that's 625, times that by 5, I believe that gets us to our number. So 1, 2, 3, 4, 5. So 5 to the 5th, which is really 5 to the 5 over 5, which would be 5 to the 1st. So all of that equals is 1, because we did have that equal to that. Alright, now this last part here, okay, the set, now we're going to do what we kind of talked about today. We're going to expand these logarithmic expressions. Okay? So, in order to do that, we need to know the rules. Okay, we have 3 basic rules. The product rule, quotient, power. Tells us if the 2 things right here are multiplied together, I can split it up and add them. If they're divided, I can split it up and subtract them. Notice my bases stay the same. If one's raised to a power, I can just go that power multiply the other. Okay? So first, we've got multiplication here. So I just rewrite it, log base 5 of 7 plus log base 5 of x. 14, 10 times a, I go log base 5 of 10 plus log base 5 of a. For 15, now it's division, so we do multiplication or subtraction. Log base 5 of 5 minus log base 5 of b. Now, could log base 5 of 5 become 1 and that's really 1 minus log base 5 of b? Yeah, but we're not worried about going that far. We're just worried about expanding it. Okay, so 16, we have log base 5 of d minus log base 5 of 4. So fairly simple in that respect, right? Okay, 17 and 18 are now the power rule, where you essentially just take that power and put it in front. So 3 times log base 6 of x. 2 jumps in front. 2 times log base 5 of 9. Now we're going to get more complex. Okay, so I can combine rules together. So first, I would go that, so I'd have 4 times log base 2 of 7x. Then it's multiplication, so I split it up. So I get 4 times, and this time I put it in parentheses because I'm splitting up the latter part. And then I just split it up like that. Okay. For 20, we change that radical to be w to the 1/2, and then we bring it down front, so it's 1/2 log base 3 of w. Okay? So that's all we have to do on these. So 21. Okay, now notice I've got those being multiplied and those being subtracted. So let's do it actually above. So I'd go log base 5 of x plus log base 5 of y plus log base 5 of z, that was my top, minus the bottom, because we have the division, log base 5 of w. Okay, now 22, now we're getting more complex. So I'd go log base 5 of 9 plus log base 5 of square root of x minus log base 5 of y cubed. But what do I notice? I've also got these powers. So instead of 3 up there, right, we take that 3 and we boot it down there. So it would be minus 3 times log base 5 of y. But I know square root of x is really x to the 1/2, which then I can jump it down in front. So I go 1/2 times log base 5 of x. So 1 term, 2 terms, 3 terms right there. Okay, let's look at 23 now. 23 will shoot up here. Okay, now this x squared minus 4 is together. So I go log base 2 of x squared minus 4. And I can't do anything to that because it's got the minus inside. Okay, so that one I can't touch. Minus, now this power of 3, I would have log base 2 of x cubed, but I can bring it down, so minus 3 times log base 2 of x. And that's as far as we can go on that one. Okay, then 24. Now see, this one's just x squared, so that 2 can jump down in front, so I get 2 log base 2 of x, then minus, and I'll use a parentheses here because those two are together but they're in the bottom. So I can split them up with an addition, okay? And I notice, and I'll do this step by step, so log base 2 of y to the 5th plus log base 2 of w cubed. But then I can move that in front and I can move that in front. So we could actually write it like this. So minus 5 times log base 2 of y plus 3 times log base 2 of w, and there's my complete answer for that one. And once again, we're just using those 3 rules in different combinations as needed. Okay, now just review, remember converting. Remember our idea is that the base of the exponent is equal to the output, and we convert it to the log of the base b of the output to the input. So 2 stays a log, so I have log base 2 of 512 is going to equal my exponent 9. Okay. And now for this one, my base is 10, so log base 10 of 0.01 equals, you said it, -2. And finally, even though they're fractions, we go log base 2/3 of 3/2 equals -1. And then on the last 3, just going back the opposite way, that's the base of my exponent, that is my exponent, and that's my output. So the base 1/3 to the 1/2 -1 equals the input. Base of 2/5 to the 3rd equals 8/125. And there we go, guys. That's all we have.